Hello students, today we will discuss about JEE Mains 2015 physics paper. Now we will discuss all the questions one by one. Okay, let us start. Students, let us move to the next question, question number 26. Assuming human people to have a radius of 0.25 centimeter and a compatible viewing distance of 25 centimeters. So this is the distance of distinct vision in one way. The minimum separation between the two objects that human eye can resolve at 500 nanometer wavelength is. That means what? This question is basically about the diffraction of light, and assuming human people to have a radius of this, so the radius of human people is given as 0.25 centimeter. So this is the suppose the people, okay, through which light enters, and we will see this, and its radius is this r, which is 0.25 centimeter, and obviously then if you think of the diameter, then the diameter, so diameter d should be twice the radius, so it is 0.5 centimeter. So this is 0.5 centimeter. Now what is given is the wavelength to be resolved. The minimum separation two objects that human eye can resolve is this. That means the distance is not in millimeter here, it is in nanometer terms. So obviously if the distance is in some millimeter, then we can resolve it because our meter scale is also of mm, and we can resolve it. Even we can resolve much below than that in slide calipers and screwers. So therefore it says that the minimum distance that you can bring the two objects closer, then we can just resolve. That means it is 500 nanometer, and if I bring the two objects by 500 nanometer separation, then I can see those two objects clearly as separate objects. But if I bring the distance less than that, I reduce a little less than 500 nanometer, then I will see this as one object. So I cannot distinguish the two objects. So this is our limitation. So the human eye has a limitation of 500 nanometer objects. Okay, the wavelength here is 500 nanometer. That means this is a resolving wavelength. That means if the wavelength is less than this, then we cannot resolve. Okay, if it is greater than that, it's okay, fine. But if it is less than this, then we cannot distinguish the two objects as separate objects. So now we have from diffraction of light. We generally use one relation that I'll write here. From diffraction, we use a relation that is path difference should be that is d sine theta should be lambda, a multiple lambda, path difference that is d sine theta should be equals to some lambda. This is for the constructive interference to occur. This is the condition for the this is the formula that you are using for for spherical objects. We use it as 1.22 into multiplied by 1.22 for circular aperture. For the circular aperture, we use 1.22. So from here, actually, sine theta comes out to be 1.22 lambda divided by d. Okay, so d is this pupil diameter. I can draw this diameter here, no problem that. So these are the two diameter. So this d sine theta. So from here, I will put the value of and get the theta. If I substitute the value, it is 1.22. Lambda is 500 nanometer in the question, so it is 500 nano means 10 raised to minus 9. Okay, divided by d is 0.5 centimeter, which is 0.5 centimeter. I convert it into meter. So now this is in meter, this is in meter. There is no unit of this because it's sine theta, dimensionless quantity. If I solve this, then what I will get? If I solve this, then so half is 2. So 5 by 10. So 5 cancels. This is 1000. 1000 and this 2 goes 10 raised to 5. 5 and this is 4. So it is 10 raised to minus 4. And this is 1.22. 1.22. I hope you got this. This is 5 by 10. I make it. So 5 cancel. 10 is 3 here. 3 and 2 is 5. 5 and 9 from 5 is minus 4. And 1.22 is left. So this is sine theta. Okay. Sine theta is this. Now the question is you have to find the minimum separation between two resolve. This is the minimum separation between the two objects that we can resolve at this wavelength. So the wavelength that we are using is 500 nanometer. So what minimum separation that you can see using this wavelength, because the separation also depends on the nature of wavelength used. If I use 500 nanometer, then a particular angle or a particular angular separation or particular linear separation can be seen. And if I change the wavelength, then that will also change. That means the angular separation or linear separation will change. So first, what I explained to you is about that 500 nanometer is the limit of resolution, but it is not so. It is the wavelength that is used to see the objects. So the angular separation you have to find actually. The linear separation or angular separation you have to find, and that you have to find in terms of linear distance, that is like that. Okay, so this is light used to see the objects. So this is not the angular separation or linear separation. Now, what angle subtends at the eye is this? Then I will have the distance of. We know that the distance of comfortable viewing is given as the. So this equation you will remember. We'll keep mind as equation 1. Next, I will use other pen. The distance of comfortable viewing is the diameter. D equals to 25 centimeter is equal to 0.25 meter. Now the question is what is the minimum separation? Okay, I will call that minimum separation as x. Let x be the minimum separation. X be the minimum separation between the two objects, between the two objects that the human eye can resolve. Human eye, so human eye can resolve. Now, if I say that x is the separation, this x between the two objects, object 1 and this is object 2, and this is the angle subtended at the eye, which is theta, then I'll write that sine theta from here and is x by d, because this d is the sorry, actually wrote small d and capital D, don't get confused. That small d, the capital D is for the comfortable viewing, that is distance of distinct vision, and small d I used for the diameter of the pupil. Okay, so don't get confused that. Now here this d is the distance of distinct vision, so this line and this line is approximately we consider as same. Then angle is arc length upon the radius, that also you can use. So sine theta is very very small, so sine theta is something p by h, something like that. P by, this is base, this is p, and this is h. So that way also you can do. But then sine theta is x by d, and from here I'll write x. So what will be x? X will be d sine theta. Sine theta I got in equation 1, which is like so. So this is the sine theta value. So I'll do here multiply that. So x becomes d, which is 0.25. Okay, this is 0.25 meter into the sine theta, which is 1.22 and 10 to the power minus 4. So if you solve this, what will you get? Then this is 1/4 of this value. If I divide by this, actually 1/4. If I divide by 4, then I will get 4 3s are 0.3 and something. So let me see the 3 number before going for the actual calculation. So I have got in 3, I have got 2 choices, 30 micrometer and 300. So I have to solve this. This is 0.3, nearly 1.22 divided by 4 into 10 raised to minus 4. So approximately you should solve like that only, 0.3 something. I'm not interested in something. So 0.3 into something makes x. I'm not interested in this value at all. Into 10 raised to minus 4 meter. Now in the options are in micrometer, so I'll do one thing. I'll multiply here 0.3 and I don't count the next part. So 0.3 I'll take. I drop this whatever value comes out here. So 0.3 into 10 raised to minus 4. But then I'll multiply 100 and divide 100, so that this will be converted into micrometer. If I divide this whole thing together, is converted to micrometer. So from here I write 0.3 into 100 into 10 raised to minus 6, because this 2 will go with negative and becomes minus 6 meter. So this thing together is called micrometer, and this 100 is multiplied with 0.3. So and it comes out to be 100 is multiplied by 0.3, so it comes out to 30. So 30 micrometer. If I see the option, then you can see here 30 micrometer. This is the correct answer. So what we have done is, we did not go for actual calculations and save the time and still got the right answer. So in many of the questions you can go for this. Okay, because before you going for the actual calculations, just have a look at the options. In the options you will see that which answer is the best preferred answers. So therefore, if I'm not interested in the other digits which is placed after the fourth digit after decimal, because the options are not there, so approximate answers are there. So therefore I don't need this, I want only this 0.3. From 0.3 I can get the answer. So this is the right answer to this question. So option number 2 is the correct answer to this question. Okay, thank you.